Okay, class, picking up where we left off at. I told you all to cross out 23 and write 22 to go along with your answer key. It says, using the table last page of the review for the number of text messages sent in a day, we want to use stratified sampling to estimate the average number of text messages sent considering females separate from males. We will pick 10 random people using a random number table of 1 through 200. Of the 200 students that we have collected data on, 41% are males and 59% are females. We want our sample of 10 to be represented proportionally as they are on the text message table. How many males will you pick from the table? Okay, so it's 41% male, 59% female. So you're supposed to take the total of 10 that's needed and multiply by 0.41 to represent the males, and that would equal to 4.1, and we will make this approximately, because it said round to the nearest whole number, it will be 4 males. Next, for B, how many females will you pick from the table? So we would take the same 10 and multiply by the 59%, which is 0.59, which is equal to 5.9, which is approximately 6 females. Okay, now, the next thing. It says, using the random number table, start at 61 and move down the column to select the necessary number of students. Enter your data in the table below. Okay, listen. I want you to copy this data down in your tables. Push pause, copy this data down, and I will show you where I got this data from. But copy the data down in your table. Okay, now, it says here, for D, it says compute the mean number of text messages sent a day for the stratified sample of 10. Now, we have 4 values for the males, 6 values for the females. So what we would do is we would add up all of the text messages that were sent, which would be 9, 16, 21. Yeah, I just put all the rest off camera. So we have all of the values for the text messages that we would enter into the calculator. 9 plus 16 plus 21 plus 0 plus 6 plus 3 plus 28 plus 45 plus 13 plus 17. We will get that answer, which is 158 divided by 10, and that will give us exactly 15.8. So that would be our answer here. It says if we consider the 200 students a population, then the population mean is 15.21. What is your absolute error? Okay, so we would take 15.21 minus 15.8, and they said absolute error, so we would do absolute value. So that would give us approximately, well, actually it'll be exactly, because we're subtracting these numbers here. It would give us 15.21 minus 15.8, which will give us a negative 0.59, but we know since it's an absolute value, it will give us a positive 0.59, which is 59%. So that is your margin of error. Okay, so one little error here. You should have just left it, I should have just left it at 0.59, and we were supposed to take that value, the 0.59, and divide it by the estimated value, which is 15.8, and then we would take that and change it to a percent. So we'll take 0.59 divided by 15.8, and that would give us, we have this long decimal here, and we would just round it to the nearest percent, so that would give us 4%. So the error is about 4%. All right. So now it says here, what is your absolute error and percent error? How could we lower the percent error? Okay, so now remember, this was your absolute error. This is your percent of error. Now it says, how can we lower the percent of error? Basically, if we got a larger population that's more representative of the population and get the correct ratios of males to females. Okay, now, how I got these numbers for this table. You don't have this with your review, but we're going to scroll down here to where it is located with your review. And what you could do, you could take a picture of it. This is where I got these numbers from. It was from this table here, and then that's the rest of the table here. So this is the full table. Matter of fact, let me make it smaller so you can see the whole table. This is the table here. Okay, so now you can take a picture of it so you can compare it with the data that I put in this problem for you. Okay, now we will go to the next page. Now I know on the review that you have, your next page has 23 and 24 circled, and then 25 is crossed out and written as 24. But what I have here is a more up-to-date version of the review. And actually, on your review, your 23 and 24 that's circled, we don't have to do those problems. So you'll go to your number 25 that you made 24, and here is the 24 here. So we're going to go over that now. It says an internet provider conducted a survey to measure customer satisfaction. They sent out surveys to 1,200 customers in the mail with return envelopes. After a month, they received 250 completed surveys. Only 75 of those surveyed were happy with the service. It says, what is the response rate for the internet provider survey? So it was only 250 out of 1,200 that responded. Now, we could write that as a percent, so it'll be 250 divided by 1,200. And that would give us, and we could do it as an approximation, we could round to 20.83%. That was the response rate. Okay, now 25 is actually your 26. So it says here, what is the purpose of random selection in a statistical study? It says, A, random selections allows us to reach cause and effect conclusions. We know that that is not correct, because random selection does not have anything to do with cause and effect. It says here, B, random selection creates a sample that is likely to be representative of the population. We know that that is correct. That is why we do a random selection, so it'll be representative of the population. Now we look at C, random selection guarantees that we will not make an error when generalizing from the sample to the population. We know that is not true. And then D, random selection allows us to control the size of the sample. That's not why we do random selection. Okay, now we had 26. Now this 26 is actually 27 in your course in the review that you received. It says one benefit of selecting a simple random sample from a population of interest is that it basically eliminates the possibility of selection bias, because if you're doing it randomly, you're not biasly selecting the people. Okay, now we go on to the next problem. Okay, now this problem 27 is actually problem 28 that I had you all cross out and put 27 for. It says a researcher plans to carry out an experiment to investigate the effect of room temperature on exam performance. 40 students taking an introductory psychology course have volunteered to be subjects in this experiment, were randomly assigned to two experimental groups. One group took the exam in a room where the temperature was 65 degrees, and the other group took the exam in a room where the temperature was 72 degrees. Which of the following statements about the conclusions that might be drawn from this experiment is true? Now, just to cut through this, the answer here would be C. It would be possible to determine if differences in room temperature were the cause of any significant difference in exam performance for these 40 students, but would not be possible to generalize this results to all students in an introductory psychology course. Because remember, this is just one course, so we can't base one course over all of the courses or over all of the college. And basically, when you read the other selections, you notice that there is that type of, that type of error with each one of these. Either they're talking college-wide or past the one course. Okay, this problem 28 is actually 29 in your review packet that I told you to cross out and put 28 in its place. It says, suppose you are interested in investigating the effect of exercise on blood pressure. Which of the following would be appropriate? Okay, so now basically it would be C, an experiment in which 100 volunteers who currently do not exercise are randomly assigned to either an exercise group or no exercise group. Those in the exercise group exercise daily for 6 weeks. After 6 weeks, blood pressures are measured and the two groups are compared. So this would be most appropriate out of the others. Now, if you have any questions about the others, please bring them to class and we can discuss them. Okay, now problem 29 here is actually problem 32 from your review packet that I had you cross out and put 29 in its place. So let's go through this. It says in an experiment to examine the effects of sugar on hyperactivity in children, a researcher randomly splits a group of 75 children into 3 groups. One group receives a sugary drink with 30 grams of sugar. Another group receives a drink with 15 grams of sugar. The third group receives a drink with a sugar-free sweetener. The children are then watched while they play and given a score between 0 and 30 on the standard hyperactivity scale. Part A, what is the explanatory variable in this experiment? And we know the explanatory variable is the amount of sugar consumed. And then it says, what is the response variable in this experiment? It will be the child score on a hyperactivity scale, because we know the explanatory variable is basically the independent variable and is the one that we're checking to see if it causes the response variable, which is the hyperactivity scale. Okay, now this is basically it from the review that I gave you. But there are actually 3 additional questions that were added to the review that I'm adding to this video and then the next video. So what I want to do is scroll back up here. So you do not have this problem in your course pack. So I'm going to minimize this a little bit so you could take a picture of it and you could include this. Okay, we have 22 A, B, C, and D. Now you do have it in the answer key that I gave you all. This problem 22 is in the answer key that I gave you all, but not on the actual final exam review. So it says here, the logistic curve can be used to represent the amount of medication that is in the body after the medicine is ingested. A person ingests 1,000 milligrams of a medication. After 27 minutes, there are 500 milligrams of the medication in the bloodstream. After 54 minutes, there are 794 milligrams of medication in the bloodstream. It says, what is the carrying capacity? Now, according to this here, the carrying capacity is this 1,000 milligrams. Now it says if B is a negative 1.94, write the equation that models the situation. The equation that models the situation is y is equal to 1,000 divided by 1 plus x over 27. And of course, we would take that to the negative 1.94 power. Okay, now, just to go over this. Now, we have this equation here. And it looks as though I'm going to have to complete this on the next video, but let me finish up part C. It says, draw a graph of the situation. Label the asymptote, inflection point, and axis. And then D, it says how many milligrams of medication are in the bloodstream after 63 minutes. Now listen, I'm not going to draw this. You all have this on the answer key I provided to you.